The distance needed to stop a car, d, varies directly as the square of the speed, s, at which it is traveling. A car traveling at a speed of 70 kilometers per hour requires a distance of 40 meters to make a stop. What distance is required to stop a car traveling at 80 kilometers per hour? Okay, so first thing I recognize is that we have the topic varies directly as the square of speed. So we're looking at direct variation, right? So d varies directly as the square of speed s. So the first thing I do is to write out that equation. D varies directly as the square of the speed s. So the square of s is written like that, the square of s, or s squared. I can translate that into an equation where I have k s squared. So because direct variation, the equal k comes in to replace this symbol here, the alpha symbol here. All right, so we need to find what k is. So we need to know what d is when s is a certain value. So let's read the question again and see if we have that information. We're told a car traveling at a speed of 70 kilometers per hour requires a distance of 40 meters. So we have the speed being 70 kilometers per hour when distance is equal to 40 meters. So we're given the two values for d and s, so we can use to find k. That's the idea with these things. You gotta always have the two variables, the values of the two variables to find k, the unknown. So d in this case is going to be 40. Let's write that. K we're not sure. We're trying to find that. S is going to be 70. We're going to square it. Now we want to find what k is. All right, so we can do two things here. Let's write back the 40. Let's write back the k. And square of 70 is going to be 7 is 49. So that's going to be 49. And square 0, okay, that should be 20 there, 4900. In other words, 70 times 70. 7 7s 49, and put back the 2 zeros, 4900. Okay, now we need to find what k is. We need to divide. Since 4900 is multiplying k, to remove it, we use division, the reverse of multiplication. And so we end up with k equals 40 over 4900, which of course is 4 over 490. And we can simplify this further. If we look at it, let's see. 4 goes into 9. 2 times into 1. No. So we can divide this, divide by 2. With 2 over, and that's going to be 245. Okay, so we have the value for k. And so let's write back the original equation here, but this time replace k. So we have d equals, this k is a constant, meaning it's fixed. So k is fixed at 2 over 245. Let's write back the s squared. So d is a variable and s is a variable. Those two vary, but the k is constant at 2 over 245, no matter what the distance or speed is. Okay, so what they're telling us, what distance is required to stop a car traveling. So we want to find the distance required to stop the car at a speed of, so we're going to change speed s, we're going to change s to the speed value, which is 80, and square it. Okay, so this looks like a job for the calculator. So what we're going to do, we're going to take 2 divided by 245, then multiply that answer by 80 times 80. That is 80 squared. And so our answer is going to be 52.2. let's use that 52.24. So we're going to stop at 2. Since the next digit is actually 4, let's maintain the 2, the last 2. And that is the distance. And of course, our distance is in meters. That's what we've been using. And so it'd be 52.2 meters. Now, of course, we'd have been using rounded figures, so we can round it out to the nearest tens, the nearest whole number that is, and this could be 52 meters. Correct it to the nearest whole number.